Someone here mentioned global warming, and I just couldn't help bringing up this slide. But I have a whole talk on global warming you can get from creation.com. Anyway, I belong to this organization. We want some global warming. In fact, there's probably a foot of snow there when I get back. I haven't been home for over a month, so anyway, we will change to the real topic of tonight. It's this one right here. The Ice Age, only the Bible can explain it. Wow, what a provocative subtitle that is. Only the Bible can explain it? Well, just bear with me and I'll flesh it out for you and let you know what that all means. Secular scientists have a habit of saying that with their ideas of the past from the rocks and fossils, they can explain everything. And because we believe what we believe in the Bible is pure faith, we can't explain anything, they claim. But actually, we can explain a lot more than they think. So as a result, when you read the earth science journals, which I try to keep up with about 50 of them, not doing too well lately because it's just getting so overwhelming. They add new ones. Like they added one called the cryosphere just recently about ice. So anyway, it's hard to keep up with these. And I've been in this for 45 years. The Lord has led me to do research to answer questions and challenges that the secular scientists give us. Not necessarily to bash evolution, which if you learn just a little about evolution, you find out how easy it is and how little evidence there is for it, which greatly surprised me when I went through it. But anyway, there are hundreds of earth science challenges. We have lots of answers, but we still, since I've read all this material, I see there's hundreds of them still. I've worked on a lot of these myself. And here's just a quick list over 5 minutes right here. I'm not going to go into these, but I'm going to focus in on the Ice Age is a challenge. And what is an ice age? Let's define our terms first of all. An ice age is essentially a great increase in snow and ice. 10% of the continents have ice and snow on them now, mainly Antarctica and Greenland. During the Ice Age, 30% of the continent was covered by ice. And I'll show you maps of where it occurred later on. There's some seats up here, by the way. Also, I'm going to make the point that it's the last major event in Earth history. The last major event in Earth history. So what is the challenge of the Ice Age? Well, they say, secular scientists say, and I'm using their dates, by the way, for sake of argument, they say each Ice Age takes 100,000 years. And in that Ice Age, the glacial phase is 90,000 years, and an interglacial phase is 10,000 years. And there's been about 50 regular repeating ice ages during the past 2.6 million years. Now, you might figure by looking at those numbers that, well, there should only be 26 ice ages if they're every 100,000 years. Oh, but there's a little more to it. Over a million years ago, they oscillated every 40,000 years. And only the last million years in their time scale is at every 100,000 years. You might wonder why 40,000 and 100,000 years. It's because they believe in a certain theory of the Ice Age called the astronomical theory that is cyclical. And so they have these things in nice cycles as a result. So, and here's a quote from Arthur Strahler challenging us. And in fact, this book is a pretty thick book of challenges for creationists. It's an anti-creationist book. It's a pretty good resource for research projects. For me, creation research projects. So he says, increasing the duration of the Ice Age by a factor of about 10 greatly increases the stress upon the creation scientists, who must compress the events of 15 million years into 4,000 years of post-flood time. Now, this man did a lot of reading of our resources, and he got a lot of things right. But because he's an atheist, he got a lot of things wrong, too, what he got right was that, yeah, it's about 4,000 years since the flood, and its post-flood time was the Ice Age. And it's interesting. I've read some old Earth creationists, theistic evolutionists, whatever you call them, and a lot of times they're challenging us. And most of the time they never read our material. I mean, we've been publishing in journals for almost 60 years. The Creation Research Society Quarterly has gone through 54 years of material, of in-depth information. They hardly read it. Even the books we have out, we have hundreds of books and DVDs out there. These old Earth creationists hardly even look at that. And then they erect these straw man arguments that they cut down and think that they got it over on us. But they never did their homework. They never analyzed our position. But this guy did. He did a fairly good job as an atheist, so I give him a lot of credit. So what does it mean by he increased the length of the Ice Age increased 10 times? Well, suddenly, for some reason, probably because to align all the fossils right at that time, they believed the Antarctic ice sheet was 10 times older than they thought before. That's how come the Ice Age has increased 10 times. Interesting that they did that. They do that sometimes with these events. They just jump the time now and then. Anyway, when you get challenges like this, and I read a lot of challenges, this is my theme verse for research, but examine everything carefully, hold fast to that which is good, 1 Thessalonians 5:21. You got to examine everything carefully, beyond the superficial level, beyond the internet. I go to the journals, the scientific journals that are published. You got to go beyond the popular science magazines like Scientific American. But you got to hold fast to that which is good. I hold fast to the Bible as God's Word, and Jesus is my Lord and Savior. But then I examine all this stuff carefully. And you know when I examined it? They have all these challenges for us. I find out that most of the time, they're challenges towards them too. Once you look at the data, they're challenged also, but they bluff their way through it by adding more hypotheses. And it makes it sound like, give us some more money and we're almost ready to solve it type attitude. But we're going to test them with the Ice Age. And I'm going to present this as a series of questions. First of all, we got to establish, was there really an Ice Age? Am I trying to explain something that never existed? Are the secular scientists trying to explain something that never happened? Well, where do we find out about what ice sheets do? Well, we go to places that are currently glaciated today, and like the beautiful Athabasca Glacier in the Canadian Rockies. There's you can see my cursor, great, okay. There's the ice right there, and it was out here in 1890. And ever since about then, practically all the glaciers in the world have receded. Speaking about receded glaciers, in Glacier National Park, there's a sign there. There's two major glaciers. I've been up to one of them. Said, these glaciers will be gone by 2020. But guess what? They've been increasing in the last 10 years. And they've had to get rid of the sign. Kind of funny. But most glaciers are receding. There's some exceptions. And due to little global warming, which is only 1.7 degrees Fahrenheit, and I simplify it and say less than 50% is due to man's carbon dioxide, and more than 50% is due to natural processes. Like the Little Ice Age, where all the glaciers in the world advanced between about 1300 and 1850, 1890. And before that, we had the medieval warm period, about the year 1000. So there's natural processes, effects of the sun, ocean current effects, and so forth. So I think that global warming is more than 50% natural and less than 50% due to man adding carbon dioxide. So it's a real event. It's small. It's only 1.6 degrees officially, even though those temperature records are flawed. But anyway, let us, whoops, I didn't want to do that. Okay. The glaciers receded. What did it leave behind? Well, it left behind ground moraine, which is rocks of all sizes jumbled up in a random mixture. And then it leaves ridges in front of it like this. That's called an end moraine or terminal moraine. How many have heard of that term before? Oh, not a lot of you, okay. And along the edge you have a lateral moraine right here and over here. Moraines are formed when an ice pushes out, it pushes the debris out. And when it stops, you have a ridge of debris in the front of it called the end moraine, and on the sides it's called the lateral moraine. It's on the edge of the glacier. And here's the lateral moraine closer up. You see it's got boulders in it, and it's actually rocks of all sizes jumbled up, and a lot of times with finer, smaller rocks around the bigger rocks. That's typical of glacial debris. So that's what you see as far as the moraines go. But also, you find that the rocks, a glacier is very dirty on the bottom, and it picks up all kinds of rocks, boulders, and those boulders can shift. And so they get scratched moving across the bedrock, and they get scratched in different directions. You see one direction like this, and then there's another one like this. Whoops, come on. And there's another one somewhere. Anyway, I can't see it at the moment. And as these boulders move from the bottom, in the bottom of the glacier, they scratch the bedrock like this in the direction of movement. So this is typical glaciation area. So let's look around in a lot of places where it's claimed to have been glaciated, like around Chicago. You'll find these features around Chicago because this area was glaciated at one time. So up in my area, west of Great Falls, Montana, where I forecast the weather for 27 years, here's the Rocky Mountain front right up there. It was glaciated, and ice came over the top down to the east and ended right there. There's an end moraine right there on the flat, high plains. It's subdued. It's not sharp looking. It's quite subdued. You can see some of the boulders sticking out at the top. And it actually continued over where I took the picture. But right in here, it must have broken through, probably because it dammed up a lake behind it that broke it through, and that's where they put the reservoir in this case. So it looks like it's an end moraine from an ice sheet that was up in the northern Rockies. And when you look at the moraine, you find out it's got rocks of all sizes jumbled up, typical of glaciated areas. And then you find some scratched rocks in that moraine in different directions, one direction there, one there, not a lot of difference there. And then when you hike up to the top of the first cliff in the Rocky Mountain front, you see scratched bedrock where the glacier moved from west to east down the 800-foot cliff and about 10, 15 miles out into the high plains. So it's obvious this area was glaciated, as similar features as you see in glaciated areas today. But this area gets up in the mid-80s for high temperatures in the summertime. And you have to cool it off to at least 32 degrees average temperature in the summer. So this area is very far from forming an ice sheet. But yet the striations aren't weathered out. This area gets a lot of precipitation. And look they're still there, which means the ice age was recent. And you can't glaciate it today. It's just way too warm. So what gives? It must have had a massive climate change not too long ago. And then in a lot of the mountain areas of the western United States, you have these horseshoe-shaped moraines that come up from valleys. The eastern Sierra Mountains have them, the Wind River Mountains of Wyoming. These are the Wallowa Mountains of northeast Oregon. You have a nice horseshoe-shaped lateral and end moraine. Here's the end moraine right here, and here's one of the lateral moraines right here. Pretty sharp looking, indicating that it hasn't been subdued, so the ice was recent, and it over-deepened this area here, forming the beautiful Wallowa Lake. And this is an area that gets up in the low 90s for an average high. Very far from being below 32 degrees for an average. So it was glaciated, but it's far from it today. And when you look at the lateral moraine from down below, you see the trees for scale. This lateral moraine is 600 feet tall, meaning that the ice in this valley to the right was probably about 2,000 feet thick. And when you look at the material in the moraine, it's the rocks of all sizes mixed together with finer rocks and sand around them, typical of a glacial moraine. So this area was glaciating. So there was an ice age. Another indication are these erratic boulders that have been transported afar. And erratic boulders is a type of rock that doesn't outcrop in the local area, but has been carried somehow by water, or in this case, icebergs. By the way, this is John Woodmorappe, who is a creation geologist from Chicago. I don't know, some of you probably know him. He came to Montana and Alberta, Canada, where this picture is, and I took him on a 10-day field trip. So that's the famous Okotoka erratic boulders. And here's a famous erratic boulder southwest of Portland, Oregon. Now the ice sheet didn't come down to Portland, Oregon. And the furthest south it came in Puget Sound area is down to Olympia, Washington. This is about 200 miles south of where the ice sheet occurred. This particular erratic is a shale. It's been heated up and metamorphosed to argillite, a metamorphic shale. But this type of rock doesn't outcrop in the whole state of Oregon. So what's it doing down here southwest of Portland, Oregon? By the Lake Missoula flood. How many have heard of the Lake Missoula flood? Some of you. Oh, good. That's a good percentage. Not a lot, but still a good percentage. Well, Glacial Lake Missoula filled up with water by an ice dam here in northern Idaho. It was 2,000 feet deep right there at the boundary between Montana and Idaho. It was about 5 times the volume of Lake Erie before it broke through the ice, and it spread through eastern Washington and carved up the eastern Washington and formed what's called the channeled scablands. And from space you can see the path of the catastrophe. It was 10 times the combined flow of all the rivers in the world. It moved over Spokane, Washington, 600 feet deep. And you can see the channel here. The black is basalt and the light colored is silt. So it eroded the silt down to the basalt. You can see the pattern of a braided stream 100 miles wide. So if there's a Lake Missoula flood, there had to be an ice sheet to block and form Glacial Lake Missoula. So I'm going to skip that. So there was an ice age. There was an ice sheet. And when you add up all the pieces of evidence around, you find out this is the general locations of where the ice sheets in North America were. Practically all of Canada and the northern United States. Now here's an interesting place in southwest Wisconsin that was totally missed. So I'm going to pose the question. They claim there are 50 ice ages. How could they all of them miss one spot like that 50 times? Maybe there was only one ice age. There's also one of those up here in Saskatchewan and eastern Montana, by the way, that's not on here. So, and the mountains of Alaska were glaciated, but not the lowlands, which is a mystery of secular earth science. And that's where you find the woolly mammoth fossils and horses and bisons in the lowlands, not in the glacial ice, but in permafrost, permanently frozen soil. That's where you find them. And in Europe and Asia, this is the general location. There's some controversy over the exact boundaries of these. The mountains of Central Asia were glaciated. Just the mountains of Siberia over in here were glaciated, not the lowlands. And like I said, that's where you find millions of woolly mammoths. In this area right here, this is the New Siberian Islands. In this area right in here, you find, they estimate about 6 million mammoths that are still there in the permafrost based on the amount they have found so far. That's from the Russian scientists. But this is the general location of the ice. This is just a schematic. It's missing some of the mountains in this area. North of Norway, they discovered, based on bottom features, that shallow Barents Sea was glaciated also. So the ice actually extended way up here to Spitsbergen, 80 degrees north. So that's where the ice was, about 30% of the land covered by snow and ice during the Ice Age. So there was an Ice Age. It needs to be explained. Can mainstream sciences explain the Ice Age? You go to a course on glaciology, they might tell you, well, get a little cooling and presto, we got an Ice Age. I mean, they simplify it, make it seem like it's easy. But you go to experts on the Ice Age, you get a totally different story. But first of all, we got to find out what's the requirements for an Ice Age before we can determine how difficult an Ice Age would be from climate change. Well, first of all, you got to cool the summers down. The summers are too warm, they'd melt the snow and ice. You need cooler summers. Winters in most areas are cold enough for an Ice Age. In fact, most areas like interior Canada and other places are way too cold for the Ice Age. They'd benefit if it was warmer. You also need greater snowfall. But there's a problem. The cooler the air, the drier it is. So if you find a mechanism to cool the climate, you're going to dry the air, and so you're not going to get enough snow for an Ice Age. That's why there's over 60 theories on the Ice Age. There's only one aspect in secular Earth science that has more theories, and that's the demise of the dinosaurs. There's about 100 theories on the demise of the extinction of the dinosaurs, but in the cause of the Ice Age there's about 60. And you can't get a climate change just for one season. It's got to persist for many years for the snow and ice to build up to form an ice sheet for the Ice Age. So, is this easy to explain for them to explain? No, it's not. What kind of temperatures are we talking about? Well, a guy did a computer program where he cooled off the average summer temperature of Canada by increments of 2 degrees centigrade. That's 3 degrees Fahrenheit. So by the time he got cooled off the summer temperatures by 12 degrees centigrade, that's not down to minus 12, it's cooling of minus 12 from the average, which is about 10 degrees centigrade. His 1 inch line, he wanted to find out where the 1 inch line would last through the summer into the fall to start your Ice Age. So you got 1 inch to start your Ice Age. The 1 inch line was in northeast Canada, in this area northward, at minus 12 degrees centigrade or 20 degrees Fahrenheit. Just to northeast Canada. But the ice went clear down south of the Great Lakes. So you need a lot more cooling down in this area. How much? Well, I took Minneapolis as an average. This would be fairly similar for Chicago. The average temperature, June to August, is 70 degrees Fahrenheit. You have to cool it, that summer temperatures down to at least 32 degrees Fahrenheit. But because sunshine is the major variable for melting snow, and sunshine gets pretty intense in the spring and summer, you got to actually cool the temperatures well below freezing to keep the snow from melting. How cold? Well, I went to some articles in this journal, Quaternary Research, in the lowlands of Antarctica. When do they get net melting? In the spring in Antarctica. When the temperature warms up to 14 degrees Fahrenheit, they get net melting. At 14 degrees Fahrenheit, net melting. So I'll be more conservative. I'll say for Minneapolis, if they can cool to 20 degrees Fahrenheit in the summer, then they'd start their Ice Age. That represents a summer temperature drop of more than 50 degrees Fahrenheit. 50 degrees. You talk about climate change nowadays. Where are they going to get a climate change like that? Well, as you can guess, the Ice Age is not easy to do. Experts admit that. J.K. Charlesworth, he wrote a 1,700-page book on the Ice Age called the Quaternary Era. By the way, if I use the term Pleistocene or Quaternary, that is the secular Ice Age period. That's the secular Ice Age time period. He says, near the end of it, when he starts talking about the causes of the Ice Age, Pleistocene phenomenon have produced some great theories? No, an absolute riot of theories, ranging from the remotely possible to the mutually contradictory and the palpably inadequate. That's not saying much for those theories. In fact, one of those theories is the astronomical theory, which at that time was considered bogus. In fact, I've examined it, and the changes in solar radiation are way too small to cause ice ages. But that's all they have. They got their back to the wall, and so they bluffed their way through it with this astronomical theory. But that was in 1957, right? And we know so much more now. This is modern times, right? Well, let's get something more modern. This is U.S. News and World Report in 1997. In August, they reported on the top 18 mysteries of science. The top 18. Great science mysteries. Now, some of these mysteries were mysteries of their own making because they believe in evolution. Did anyone read the small print there yet? Why should males exist? What? What's that about? Why is that a mystery? Well, because in evolution you should have only one sex that reproduces asexually. That's the problem. They can't figure out why you get a male and a female by chance in all these organisms. But that's where our worldview, the biblical worldview, has the evidence hands down on them, because the Bible simply says God made us male and female. Case closed. Meanwhile, they publish books and articles every year trying to explain this great mystery. But some of these mysteries are real mysteries, not of their own making, and one of them is what causes ice ages. They don't know, 1997. But let's get a quote a little closer. David Alt, Glacial Lake Missoula and its humongous floods. Yes, they have to have more than one Lake Missoula flood. If they have more than one, like 50 ice ages, and they have 90 Lake Missoula floods now, it sounds more business as usual. Uniformitarianism. How many know what uniformitarianism is? Slow processes over millions of years. Uniform processes. So if you have many of these cyclical, it sounds normal, uniform. But anyway, he says, although theories abound, no one really knows what causes ice ages. And one even 2008 from the most widely read journal in the world, Nature. Perhaps the longest standing puzzle in the earth sciences. The longest standing puzzle is what causes the northern hemisphere ice sheets to come and go. So they really don't know. It's a major problem in earth science. So they can't explain it. Can we explain it? Can the biblical worldview explain the ice age? Well, first of all, we have to figure out where it occurs in our time frame. Was it before the flood, during the flood, after the flood? Well, it wouldn't be during the flood because there was a lot of hot water during the flood. And before the flood, it'd be totally eroded by the flood. And, well, to make a long story short, you would put it after the flood. And a lot of those features you saw, scratched rocks, the moraines, they're on top of flood rocks. So it's obvious that it's post-flood, after the flood. So you'd fit it into a transitional climate between the flood and the present climate. In the pre-flood climate, the evidence is lots of evidence that it was pretty warm. And there's lots of reasons for that, which a lot of people haven't thought of, in that something called transpiration, the water vapor given off by 10 times the amount of plants would cause a warm climate before the flood. And you find warm climate plants and animals at high latitudes, Antarctica, Siberia, Northeast Canada, lots of warm climate animals and plants all over the earth. So the climate before the flood was warm. But anyway, it gets into a transitional climate after the flood, which gives you the possibility that maybe the flood caused the ice age. The flood produced about 1,600 meters or 6,000 feet of sedimentary rock average on the continents, with all those billions of fossils in there. But the flood also affected the climate afterwards. Well, how did it do that? Well, the flood was a gigantic volcanic event. And so after the flood, you'd have all this dust and aerosols. Aerosols are fine particles, one millionth of a meter in diameter, a micron, they call it, in diameter. And they get trapped up in the stratosphere. The dust falls out in a matter of weeks to months, but these aerosols, they hang in the stratosphere for anywhere from 2 to 10 years, depending on how high the volcanic material went in the stratosphere. And they cause summer cooling over the land. They don't affect the water because of the high heat capacity of water. Also, the fountains of the great deep and all the volcanism that occurred during the flood would heat up the oceans. So after the flood, you'd have warm oceans from top to bottom and pole to pole. And what's the significance of warm oceans? Much more evaporation. You get 7 times the amount of evaporation at a temperature of 86 degrees Fahrenheit than at 32 degrees Fahrenheit. 7 times evaporation just from the temperature of the water. And the main difference would be at mid and high latitudes where the ocean surface temperatures are cold today. But during the Ice Age, they were warm, very warm. You could have taken a swim in the Arctic Ocean right after the flood. So there's where your abundant moisture comes from. The ocean, the fountains of the great deep, and volcanism warming the water during the flood. And the mechanism would persist, but wane with time, because the oceans would gradually cool after the flood during the Ice Age. And therefore, you can actually give an estimated time for the Ice Age based on the cooling of the oceans, which I did. I went through all this stuff in the 1980s. And here's a little schematic on the reflection of volcanic dust and aerosols. It's mainly the aerosols that do the reflecting, I might add, because dust doesn't last that long. But that's a schematic. Reflects some of the sunlight back to space, fails to heat the ground. So the Earth, especially the mid-latitude and high-latitude continental areas, would cool, and especially in the summer. And because the volcanic material falls out in 2 to 10 years, it needs to be replenished. And yes, indeed, during the Ice Age, there was huge amount of volcanism after the flood during the Ice Age. We have 700 stratovolcanoes across the Earth. Like where I'm from, Seattle, Washington originally, we have all those volcanic mountains, Mount Rainier, Mount Baker, and those are volcanic mountains, very likely formed after the flood. And yes, as Charles Wurth says, signs of Pleistocene or Ice Age volcanicity and earth movements are visible in all parts of the world. There was abundant volcanism to replenish the aerosols in the stratosphere to keep the cooling trend going. So here's kind of a schematic of it. You have warm oceans at high and mid latitude, much warmer than today's oceans there, so you'd have powerful evaporation at mid and high latitudes, caught in storms, and the volcanic dust in the upper atmosphere would cool the land where the snow would pile up rapidly on the cold land. That's a schematic of it. So we can explain it. We have a powerful mechanism to explain it that works. Then you might wonder, well, how rapid was the Ice Age? Well, this is my main evidence right here. This is it, Jenkins. Indisputable proof that the Ice Age caught these people completely off guard. Dumped on him before he got out the outhouse. Anyway, I actually used some equations for all this. I used what's called the energy budget for the ocean and then the atmosphere, because the heat from the ocean mostly goes into the atmosphere. What these are is you add up the heating terms, subtract the cooling terms, and you get a change in temperature, change in time. So if you estimate the change in temperature, you can solve for a change in time. And that's what I did. The main heating variable is solar radiation. The main cooling variable is evaporation. And there's one other variable. But I used those, but I had to estimate how much cooling did the ocean occur before the ice age reached a maximum. See, the ice builds up to a maximum, and then it melts. So I estimated that the ocean temperature right after the flood was 30 degrees centigrade or 86 degrees Fahrenheit on the average, which means when I say on the average, it means there was cool pockets and warm pockets, freshwater pockets, saltwater pockets. It was kind of variable during and after the flood, the salinity and the temperature, but the average would be 30 degrees centigrade afterwards. And we don't have any ice sheets now. The average ocean temperature is 4 degrees centigrade. And so the ice started melting, reached maximum and started melting well before the oceans cooled to 4 degrees centigrade. So I estimated about 10 degrees centigrade. You started to have a net melting, glacial maximum. That's a cooling of 20 degrees centigrade, which is 38 degrees Fahrenheit. So how long does that take? Well, I used maximum minimums for these energy budget equations, and I picked what I thought was the best one. And this is the range I got. As quick as 174 years and as long as 1,765 years. The best estimate was 500 years to reach glacial maximum, based on the cooling of the ocean. But then you got to estimate what was the average thickness of the ice, and then how fast it would melt. So I went into that, and I used how much of the snow fell over the water versus the land, how much fell where it wasn't glaciated versus glaciation. Had to figure some of those things out. Here's the ranges I got for the northern hemisphere. Here's the average, best estimate, 2,300 feet. For Antarctica, it's approximately 3,900 feet. And then you have to melt it. So I use the energy balance over snow and ice cover, which is the same thing as for the ocean. You got heating terms, which is mainly solar radiation, and you got cooling terms. And then you just translate that into melt. And so I did that. The main variable in this melt equation is the reflectivity of the snow. Reflectivity of snow varies tremendously from about 95% reflectant in fresh, cold snow to about 25% reflected with 75% absorbed in warm, melting old snow that has particles on it. Anyway, I got an average of about 10 meters a year along the edge of the ice sheet, the periphery, which would be the Chicago area, the Minneapolis area. So this is the range, 40 to 100 years, best estimate of 70 years. Interior Canada, interior Scandinavia would melt slower because they get less sunshine, cooler temperatures, but they would melt in less than 200 years. So the total time for an ice age is 700 years. That's what I calculated. So the ice age was rapid, relatively rapid. 700 years is still 700 years, but it's rapid according to what they believe. Okay, they claim there are 50 ice ages. What about that? Was there more than one ice age? Well, I actually believe in 2 ice ages. There was actually an ice age around the Garden of Eden before the flood. Now, this is the Earth's first ice age right here. I got to explain this a little because I've heard by the grapevine that I've insulted some people. But all this means is that when we were first created, communication between man and woman was perfect. By the way, this is a Dan Letha cartoon. It was perfect. But when sin entered, it doesn't work so well anymore. And I know because I've been married over 50 years. And in general, I'm going to be very general here. Women have sensitivity issue and men have clueless issues. I'm one of the clueless males, by the way. So let's move on and not... Anyway, when you examine most areas where the ice occurred, you see evidence of only one what's called a till sheet. That's glacial debris sheet. You see evidence of just one. It's just on the edges and a few other areas where you see maybe complications. Maybe you can find 2 or 3 or 4. But notice this article right here. Notice the title: A Single Late Wisconsin Laurentide Glaciation, Edmonton Area and Southwest Alberta, from the journal called Geology. 6 scientists from the University of Alberta in Edmonton re-examined the ice sheets from Edmonton southward, the glacial debris. And, you know, they used to say there was 4, 5, or 3, something like that around that area. And that was the standard at that time. But here's what they say: glacial reconstructions commonly what? Assume a multiple glaciation hypothesis in all areas that contain a till cover. Meaning they assume it, so they're looking for it. And when they find complicated areas, they automatically say multiple glaciations. In areas where there is no such evidence, like in Alberta, where they re-examined this. By the way, the Laurentide glaciation or ice sheet is the one that was over central and eastern Canada and the adjacent northern United States. That's the name of it, the Laurentide ice sheet or glaciation. And they put it in late Wisconsin time, very late in their period, very late. So, but only one now. And so what do they do to get these? Well, at the edge of a glacier, you'd find, sometimes you'd find a debris sheet of glacial debris. Then you find a sand sheet, and then maybe another sheet of glacial debris. They say, oh, that's obviously 2 ice ages. That's what they used to say. But now they know that at the edges of glaciers, they move a lot. They surge forward, they melt back, and so you can get sand or even organisms die in there before the next surge over them. So they know that one ice sheet can do that now. So that's why they've re-examined a lot of areas and find that most areas where they thought they saw more than one is just mainly one. But the whole thing is mainly an assumption. And the main assumption is because they believe in the astronomical theory that says there were 50 ice ages. And so the assumption is leading the evidence, what they see out there. Will there be a future ice age? Will there be a future ice age? What's the basis of this? What is their basis? Well, they say we are still in the interglacial cycle. It hasn't stopped. We're still in those 50 ice age cycles. Interglacials last only 10,000 years. This interglacial has a name called the Holocene, if anyone's ever heard that term before. And the last ice age melted 10,000 years ago. Uh-oh, we're about due. In fact, how many of you remember between 1945 and 1975 we had global cooling? And books and articles came out saying the next ice age is coming. I got 3 books saying that. One says, the coming ice age, can we survive it? Drought was usually one of the big things they used to say, but now they almost use the same words but change it all to global warming, I've noticed. But anyway, Daniel Grossman said in the New York Times, if the past is any indication, the Earth is at the end of another such warm period, poised to descend into a new ice age. Now, we believe everything we read in the newspapers, don't we? Well, the rainbow is a promise that God will never send another flood. The flood caused the ice age. Therefore, there will never be another ice age. Simple as that. And that's why I have that title. Because of the flood, it caused the ice age. So only the Bible really explains the ice age because of the flood. Now, the ice age after the flood came with other things and caused other things that are mysteries. So there's a lot of other sub-mysteries, I might call, that are associated with this. And so I'm going to quickly go through that. How much time do I have? What's my time factor? These are the bonus features. Oh, good. All right. Okay. I'm going to talk about 5 of these features. I'm just going to briefly talk about them. In some of my resources, I talk more about them. Deserts that were once wet. I'm going to talk a little bit about each one of these topics, but I'm going to summarize them now. The woolly mammoths in Siberia, as well as Alaska and the Yukon Territory that wasn't glaciated, the northwest part. Strange mixes of cold and warm weather animals and plants together in Ice Age deposits. Also, there was a mass extinction at the end of the Ice Age. About 65% of mammals over 100 pounds went extinct globally. 2/3 went extinct globally. I'll give you some other figures on this. And then the unglaciated lowlands of Siberia are other mysteries. These are mysteries to the secular scientists. Can we solve them from this model? Well, we can provide reasonable answers to them. Okay. All the dry areas, about 30 degrees north latitude, show evidence of lakes, streams, large rivers. And the southwest United States is quite dry. You had all these lakes there. And this lake right there is called Lake Bonneville. And it was about 6 to 8 times the size of Great Salt Lake, 800 feet deep. And while Great Salt Lake is only 12 feet deep on the average. So that was during the Ice Age. You had this big lake there, and you had other big lakes out in here and even southeast Oregon. Even Death Valley had a lake 600 feet deep. And how do we know that? Shorelines. You see the shorelines of these features all through this area. If you've ever flown into Salt Lake, look at the hills. You'll see those nice linear features like this. This is just north of Salt Lake. Those are shorelines from Lake Bonneville. There's several of them there. And here is how many know where Mono Lake is near Bishop, California? It's east of the Sierra Mountains. But before you get into Nevada, there's a big, long gap in there. And anyway, Mono Lake is a dried up playa lake. It's very salty. Anyway, it was 700 feet deep during the Ice Age, and this is the shoreline from it right here. And this is a glacial moraine coming out from the eastern Sierras. So this shoreline was cut right on the moraines, indicating that those lakes occurred during the Ice Age. Even in southeast Oregon, you see shorelines from lakes. This is very dry. As you can tell, there's no trees in the hills. Also, the Sahara Desert was wet during the Ice Age and afterwards a little. And you find thousands of pictographs of animals and people on the rocks in the Saharas. In fact, James Willard in the book The Great Sahara says this: the Sahara is a veritable art gallery of prehistoric paintings. The evidence is enough to show that the Sahara was one of the well-populated areas of the prehistoric world. Yet there is man's work, in the most inaccessible corners of the desert. Literally thousands of figures of tropical and aquatic animals, enormous herds of cattle, hunters armed with bows and boomerangs, and even domestic scenes of women and children in the circular huts in which they lived. They also find fossils of hippopotamuses, crocodiles, and other aquatic animals. In fact, Charlesworth, in his book, says in about the year 1900, they found a live crocodile in the higher mountains of the western Sahara Desert. A live Nile crocodile left over from the Ice Age.
How did he get from the Nile?
Well, because it was all wet in there. And so he ended up... So, it was wet. Why? Well, their Ice Age is cold and dry with more sea ice, less evaporation, cold water. So But this ice age, having a lot warmer ocean temperatures, was wet everywhere. Not only wet forming the ice sheets, but where it didn't form the ice sheet, you had a lot more precipitation. I did a crude estimate, and because of warm water off in the Pacific, I estimated 4 times today's average precipitation in the southwest United States. 4 times. And that was like that many areas. So we can explain all these lakes and now desert areas and wet Saharas with this model. Okay, the woolly mammoth in Siberia. Why would a mammoth or any animal want to live in Siberia today? It's a bogland in the summertime. You can hardly get around in the bogs. And it's bitterly cold. And there's no food for them to eat until July in today's climate. What were they doing there? Well, there's a lot of mysteries to this. And here's what a woolly mammoth generally looks like. Spiraling inward tusks, small ears, hair, 3 types of hair. The outer hair is 3 feet long, and other features adapted to cold. And you find a lot of other animals, but the woolly mammoth distribution's in this red area. Like I said, you find a lot of other animals in Siberia. In fact, they consider it like the Serengeti like the Serengeti in Africa. You had a huge amount of animals. They estimate millions of woolly mammoths in Siberia in the permafrost. So what would they be doing there? Well, it's because, first of all, it's a major mystery. They can't explain why the mammoth disappeared. Why did the mammoths disappear from Earth? This question remains one of the great unsolved mysteries of the past. These are mysteries. Why did they live? Why did they die? What were they doing in Siberia? Well, in the model with the warm oceans, the warm Arctic Ocean, you'd have a much warmer Siberian winter. It would not be bitterly cold there, for one thing. You probably wouldn't have any permafrost until the end of the Ice Age. There's lots of evidence for that. I have a whole talk on the woolly mammoths, which I would go into this. But a man did a computer model. He just took the sea ice off the Arctic Ocean, but kept the temperature at the freezing point of seawater, and found out how warm the temperature would be in winter. How much warmer? At the North Pole, it was 40 degrees centigrade warmer in winter. In northern Siberia, it was 20 degrees centigrade warmer. That's 38 degrees Fahrenheit. But he used the freezing point of seawater. What if the seawater was 70 or 80 degrees for quite a while? It'd be a lot warmer in those areas. And you'd have warm onshore flow to warm up those areas early in the Ice Age. You'd have a lot of precipitation, but it'd be too warm to collect in the lowlands. And about midway during the Ice Age, it turned into a grassland in this whole area, because most of those animals that you find up there in Siberia and Alaska are grazers. They ate grass. Woolly mammoths, horses, bisons, they're the 3 most common ones. Woolly rhinoceroses, which are in Siberia but not Alaska. So we can answer these questions. Also, number 3, there's a strange mix of cold and warm weather animals and plants. Now, you can explain the cold weather animals during an ice age, but what are warm climate animals doing, like in Siberia and a lot of other places, and also plants? Well, they can't figure that out because their ice age is cold, winter and summer, and dry. They hardly get any precipitation. That's why they need 100,000 years for each ice age. And so what is this all about? Well, it's not an exception, it's the rule. As this book called The Quaternary Extinction of Prehistoric Revolution, these 2 authors say late Pleistocene, that's late Ice Age communities, were characterized by the coexistence of species that today are, in biological jargon, allopatric, which means not climatically associated and presumably ecologically incompatible. They don't normally live together, but in the Ice Age they did. They call them disharmonious associations, and have been documented for late Pleistocene floras, that's your plants, terrestrial invertebrates, lower invertebrates, birds and mammals. And the most outrageous example of this is in Northwest Europe. And in England, you have hippo fossils, a warm climate animal, buried along with woolly mammoths and other cold climate animals. Don Grayson says in that same book, and then there's at least 100 locations you find this. And of course they like to separate, saying the hippo came up there during an warm interglacial and the other animals during cold glacial. But there's a problem with that, as Don Grayson says. They're found together. In the valley of the Thames, that's the river that goes through London, southern England, for instance, woolly mammoth, woolly rhinoceros, musk ox, reindeer, cold climate animals, hippopotamuses, and cave lion had all been found by 1855 in stratigraphic contexts that seemed to indicate contemporaneity. They lived at the same time. Now we can explain these things because this ice age actually had mild winters and cool summers, little seasonal contrast at the beginning. And as the ice age went on, the winters became colder and drier as the ice age ended. And so we can explain these features. And in Britain, for instance, at the beginning of the ice age, they'd have that warm water warming the air, and being very moist, just being onshore flow. It'd be a warm, moist area in Britain early in the Ice Age. And it wouldn't until the mid to late part of the Ice Age where it cooled down, where they finally got glaciation. So the hippos found a nice home up there with all that rain and warm air in Britain. And then it got cold and they were trapped. They didn't know where to go. And they stayed there for a while, and then the woolly mammoths come and the musk ox, and so they got buried together. So we can explain it by this model of the Ice Age.
Do you have a picture of the woolly hippopotamus?
No, there was no woolly hippo. Woolly rhinoceroses, though. Yeah, no, I don't have a picture of them. Number 4, mass extinctions at the end of the Ice Age. Okay, at the end of the Ice Age, now, by the way, the secular people interpret this the end of their last Ice Age. They didn't have these extinctions at the end of any of the other 49 Ice Ages. Just after the end of the last. Maybe there was only one Ice Age. Well, here's the statistics. 100 species of large animals in North America, that's 70% went extinct. And that includes woolly mammoths, ground sloths, saber-toothed tigers, your typical Ice Age animals. Europe and Asia lost 40%, Australia 90%, South America 80%, Africa only 20%. Average is about 2/3. So what caused that? Well, it's because the Ice Age had mild winters and cool summers at the beginning. But as the oceans cooled, you had less moisture, it became drier with time. By the end of the Ice Age, winters were actually much colder than today and much drier with lot more sea ice. And you have a lot more wind too, because you'd have a stronger north-south temperature difference, which drives the jet stream, by the way. So you'd have cold windstorms, drought worldwide during at the very end of the Ice Age. But the ice sheets would still melt because they wouldn't get hardly any snow in the winter. And then the sunshine would melt them during the summers, which would be warming slightly. So we can explain this. Well, they can't. In a book about this, after many decades of debate, the North American end Pleistocene megafaunal mass extinction remains a lightning rod of controversy. This has been a mystery for 200 years. The extraordinary divergent opinions expressed in this volume show that no resolution is in sight. They keep arguing. One of their theories is that man killed them all within 100 years when he first came to Australia and when he first came to North America. That's what they say. And others say, no, we think it's climate change. So they've been arguing for 200 years on that. Also, the unglaciated lowlands of Siberia are a major mystery. Now, they run these climate models for all sorts of things, not only global warming, they do it for the ice age and other things. So when they run ice age models, they find out that it's very difficult to form an ice age, but they can force it in the model. So in this model, right, here's a schematic of the mountains being glaciated in this purple, and the lowlands in the yellow being unglaciated, like I've already shown a similar slide. Anyway, in this model, in the Journal of Climate, these two researchers forced glaciation by decreasing the sunshine 6%. That's quite a drop. So they did get glaciation, but guess what? It was in the wrong spot. They say, we now have glaciation, but mainly outside the area where it existed during the last ice age. And this included the lowlands of Siberia and Alaska, as well as the highland, and also Tibet, which was not glaciated during the ice age. Some of the mountains that were glaciated during the ice age, but not the high plateau of Tibet. But it was in their model. So it's a major mystery. Anyway, in summary, the ice age was a real event not that long ago. It is a major mystery for evolutionary science, not us. Noah's flood caused the transitional climate for an ice age. The ice age lasted only 700 years. We don't need 100,000 years for an ice age. There was only one ice age. Only the Bible explains the ice age because of the flood, and there will be no future ice age. Some concluding thoughts. Creation scientists have a viable mechanism for the last major event in Earth history, while evolutionary scientists are far from a solution. Then why should we believe them for all those older events? The demise of the dinosaurs, the origin of the dinosaurs, the origin of all those animals and things you see in the fossil record, the death of them. I mean, they got thousands of just so stories about all this stuff in their publications. Why should we believe any of it? They can't explain the last major event that affected planet Earth. Some more concluding thoughts. The Ice Age is an example of what can be done with those hundreds of other Earth science challenges to the Bible that I introduced you with. And I've been working on these things for years. And often I find solutions, sometimes I don't. But I don't expect to be able to answer every question because we don't know that much. There's still a lot of unknowns in the earth sciences, and no one's smart enough to get all that massive amount of data that's available to put it together, what is available, not to speak of that which isn't available. Also, the issue of time. I just finished writing a book on deep time. This just came out. I don't even have a slide on it. This book, I was motivated to write this because of pastors saying, what about these millions of years? You know, and we didn't have any decent layman's books, so I geared this for a person that knows nothing about science, hopefully. That's the way I aimed it. Whether I succeed or not, I hope I succeed. But anyway, for a total layman that knows nothing about science, because a lot of people aren't science, they have no interest in it. Some of my grandchildren are like that. It's all right. It's fine. They like other things. Anyway, time is not a side issue. The short time scale of Scripture from Genesis 5, 10, and 11, and some of the statements of Jesus saying that Adam was created at the beginning of creation, for instance, in Mark, I think Mark 10:6. The other things indicating a young earth. It's not a side issue, but I have found sometimes it's key to solving major mysteries that have been lasted over 150 years. How so? Well, in regard to the Ice Age, they recognize that when volcanoes go off, good big volcanoes, not Mount St. Helens, believe it or not, was a small volcano. It didn't affect the climate at all. But big volcanoes like Pinatubo, Krakatoa, and Tambora in the 1800s, and some of these they cool the climate, but it's only for we haven't seen any that go really high, so it's been about 2 to 4 years. So they know this, and there was a lot of volcanism during the Ice Age, but they stretch that Ice Age period out to 90,000 years for their glacial phase. 90,000. So each individual volcano affecting the climate only 2 to 4 years is insignificant, you see. But what if you telescope all that volcanism within a couple hundred years? It becomes a very powerful mechanism to cool the continents in the summer. So the short time scale is key. I also have another reason why I don't believe in millions of years. I was a weather forecaster. Don't throw tomatoes at me. And I did this. I was a weather forecaster for 30 years. I'm retired. By the way, this is a Dan Leith cartoon again. And so tell me why I should trust scientists' ability to be accurate about life on Earth millions of years ago. When I first joined the National Weather Service after being in atmospheric research for about 6 years, we could hardly forecast the weather the next day. And when I became a forecaster, the way it works is you got about 50 variables measured over isolated spots on the Earth, and you got to make a decision: is it going to rain or is it not? Yay or nay? Well, you can't go yes or no, so you get probabilities on it. And, you got to say which variable is predominant. Well, I think this one is. You come in the next day, oh, wrong. You realize how complicated even the weather is. So why should I believe them when they talk about millions of years dating this rock and so forth? So right away, this kind of being a weather forecaster really helped me be a creation researcher. Okay. More concluding thoughts. The Ice Age is based on the flood. Therefore, the flood, one of the most despised events by the culture, is a real event of the past. Therefore, it is easy to believe the whole Bible, not only its history, but its spiritual message, which tells us how to live here on earth and how to go to heaven. And as you might know, I've written a lot of resources, about 7 or 8 just on the Ice Age. And my wife and I have had a desire to reach children about these things so that they can counter a lot of the propaganda they get in the public schools. And so we wrote a book called Life in the Great Ice Age. It's a fun story from a 12-year-old boy and his dog living in a cave. There's your caveman. And meeting Neanderthal men, which are just a variety of people, that's all. Having a good time in the summer, so forth, teaching about the Ice Age and lots of other things. And then we wrote a sequel, uncovering the mysterious woolly mammoth, to that, focusing on the disappearance of the mammoths and why that happened. Whoops, what's that? And because we wanted to reach children, and geology is where it all started in the late 1700s. That's where the millions of years came in. So we feel a need to let young people, as well as adults and grandparents, learn a little bit of geology from a fun cartoon character, Mr. Hibb, teaching you about the basis behind the millions of years also, so that you can withstand it in the culture. And we wrote another one called Exploring Dinosaurs with Mr. Hibb. And of course, there's the weather book. I couldn't help, and in that you'll read about the Ice Age, a little bit about global warming, acid rain, just basic weather. And I decided I wanted to look at the major dinosaur challenge for creationists, how to explain dinosaur tracks and eggs and scavenged bone beds early in the flood. How do we explain that? This is a challenge. So I wrote a book, and I also told, at the same time said that secular scientists have their own challenges and mysteries. So I go through that, but I especially focus in on dinosaur eggs. And just recently, John Reed and I wrote a summary of the flood. This is a summary starting with what was the pre-flood world like? Did we have rain? Was it warm? Why? And then I go through the early flood, late flood, and what the flood caused afterwards, the ice age. Just kind of a summary of the events and how you can relate it to the real world, the rocks and the fossils. And I want to leave you with this quote. Your faith should not rest on the wisdom of men. That's evolution. That's millions of years. Trying to explain everything without God. But on the power of God. God has tremendous power. If He can create the universe, He can do anything. He can even save us, which He did do. Amen. And there's a bunch of websites of interest. iFavorCreation.com. 11,000, more than 11,000 articles for all ages, or any age, and any scientific ability. Like if you want to learn about dinosaurs, you have to use the search engine, dinosaurs. You'd probably get 200 articles you can read of various types. And here's my website where I have 2 free ebooks on it. So that's all I have for tonight. So I thank you.
Great, Michael.